You know, when you pour a glass of water, do you ever stop and think about its journey? I don't just mean from a river or a lake, but through this hidden world of pipes and pumps and massive tanks. It's a journey that's guided by something you probably wouldn't expect, a whole lot of math.
So really, how much math is hiding in that one glass of water? Well, it turns out it's a lot more than you'd think. And getting that math right is one of the most critical parts of keeping our entire water supply safe and clean for every single one of us.
Yeah, behind every single faucet, there's this enormous, intricate system. And the folks who run these facilities, they rely on a fundamental skill every single day, calculating volume. And they do it using the kind of basic geometry you probably remember from high school. All right, so let's pop open the toolkit here. To really get how our water's managed, we've got to start with the basic shapes that hold it. And you know what? It really just comes down to two main designs. First up, you've got your rectangular tanks. They're basically giant concrete boxes. Super useful for processes that involve a lot of mixing and churning, like aeration. But then you've got the circular tanks, and these are way more common. Their shape is just perfect for processes where things need to settle down, like clarifying the water.
So, calculating the volume of one of those rectangular tanks, it's about as straightforward as it gets. You just multiply its length, times its width, times its height. Boom. That simple formula gives you the total space inside in cubic feet.
Now for a circular tank, the formula looks a little more intimidating, but the logic is exactly the same. You're just finding the area of the circular base and multiplying by the height. That 0.785, it's just a handy shortcut, a little cheat code really. It's pi divided by 4, and it lets you find the area using the tank's diameter. Once you have that, you just multiply it by the depth of the water.
Okay, so now we have our volume in cubic feet. Great, but here's the thing. In the water industry, nobody really talks in cubic feet. To make these numbers actually mean something, you have to translate them into the language they really use, gallons.
And this right here, this is the magic number that makes it all work, 7.48. That's how many US gallons can fit inside a single cubic foot. This one number is the key that unlocks the true capacity of any tank, turning an abstract measurement into a real-world quantity you can actually picture.
So the whole process is actually beautifully simple. Step 1, you do the geometry we just talked about to find the volume in cubic feet. Step 2, you multiply that number by 7.48. That's it. You've just gone from a blueprint measurement to a real-world capacity.
And this is where you really see the scale of what we're talking about. A 3,000 cubic foot tank. That's kind of hard to visualize, right? But knowing it holds over 22,000 gallons of water, now that paints a picture. That's the power of this simple conversion. Okay, but so what? Why does all this really matter? Well, because knowing the volume of a tank isn't just some inventory exercise. These calculations are directly tied to the safety and the effectiveness of the entire water treatment process.
It all comes down to this really important concept called detention time. This is the amount of time that water has to sit in a tank to be treated properly. If it moves through too fast, nasty stuff doesn't have time to settle out and disinfectants don't have enough time to do their job. And it's the volume of the tank that determines that critical detention time.
And here's a perfect example of how it all comes together. Let's say a plant is treating 500,000 gallons a day, and that water flows into a basin that holds 250,000 gallons. Well, the math is pretty easy, right? The basin holds exactly half a day's worth of water. That means the water gets a full 12 hours of detention time, which is exactly what's needed for it to be treated properly.
And it's not just about time either. Having an accurate volume is absolutely essential for chemical dosing. Operators have to add very precise amounts of disinfectant. If you add too little, the water's not safe. Add too much, and it can be wasteful or even harmful. You just can't get that dose right if you don't know the volume down to the gallon.
Of course, the real world is always a bit messier than a clean formula on a whiteboard. So for our last section, let's get into a few pro tips, the kind of on-the-ground practical knowledge that operators use every single day.
This right here, this is the golden rule. When an operator is calculating volume, they're not measuring the total height of the concrete wall. They're measuring the actual depth of the water inside. That's the operational capacity, and that little distinction is absolutely critical for getting everything else right.
And there are other real-world factors to think about. That H for height doesn't include freeboard. That's the mandatory empty space at the top of a tank to prevent overflows. And over time, sludge can build up at the bottom, which reduces the effective space. And hey, not every container is a perfect box or circle.
All of this requires constant adjustment and a whole lot of precision from the operators. So the next time you fill up a glass from the tap, maybe take just a second to think about that unseen journey your water took. A journey made possible by massive tanks, by careful timing, and by the simple, elegant, and absolutely essential math that keeps it all flowing, safely, right to you.